Hello friends, the CG Lab program 4, draw a color cube and allow the user to move the camera suitably to experiment with perspective waving. Defaultly our camera program will be in a orthographic waving and we have to set it using in a perspective waving using a function called GL-Frustum. So this is the program. We have used header files and we have declared 8 points needed for our cube of floating point data type. Coming to the main function, the main function starts with two parameters, argument count and argument vector. Next, to initialize the glut, we have used two parameters, glut init display mode. We have initialized a single buffer and a depth buffer. Next, glut init window size to initialize the initial width and height of a window. Glut init window position, top left corner we have initialized. Next, glut create window, create a window with the title spinning color cube 2. Next, we are calling a display function. We have defined the display function here. In the display function again we are using a GL clear. We are clearing the color buffer bit and the depth buffer bit, and we are loading the identity matrices. Next, GLU lookat. This function is a camera function which is used to define a camera position, which is having 9 parameters. So the first 3 parameters are I parameters, IX, IY and IZ. The next parameters are center X, center Y and center Z. And the next 3 parameters are up X, up Y and up Z. And we're going to call a function called polygon 1. So this is a polygon 1. So again inside a polygon 1 again we are calling a function called polygon. We are passing a parameters 0, 1, 2, 3. The vertices are 0, 1, 2, 3 we are passing, and this is the polygon definition. So using this 4 parameters 1, 2, 0, 1, 2, 3, that is A, B, C, D. So it is pointing all those vertices with colors you have defined. GL color 3F, GL vertex 3FV, 3-dimensional floating point. V is a vertices which has defined using an arrays in the initial itself. So we have 4 points defined here inside a polygon. So therefore it will call 4 times the polygon function. So we have 4 faces, 4 faces of a polygon. Sorry, these are the 6 faces. Polygon. We will call this 6 times. So this 6 faces has been drawn inside a polygon. As we need the input from the keyboard, we have to call the callback function glut keyboard function key in the main. So this is the void key. So before that, as we have told, it is defaultly in the orthographic weaving. So we have to convert this into a perspective weaving using GL-Frustum. So in the GL-Frustum, we have 6 parameters. One is left, right, bottom, top, near value and far value. The near value should be lesser than the far value. So this GL-Frustum, it affects the projection matrix. So it should shift from the model view. Defaultly it will be in the model view matrix. So while we are using this GL-Frustum, it should affect the projection matrix. So we are initializing the projection matrix. After initializing this projection matrix, after loading the matrices, we have called a GL-Frustum. After that, after everything happens, again we are defaultly converting the projection matrix into a model view matrix. So coming to the key here, using a glut keyboard function key in the main function. So this is the definition of a key, where you are checking what the character consists of, whether F consists of small x, capital X, capital Y, small y, capital Z or small z. If character matches with the small x, move the camera towards the negative axis, x axis. If it matches with the capital X, move the camera towards the positive x-axis. The same wise for Y, for small y, capital Y, move the camera towards the negative y-axis or positive y-axis. For small z, negative z-axis, or for capital Z, move the camera towards the positive z-axis. And display, again you are calling the display function to again the display whatever you have been changing using your keyboard keys. So this is your program. When you are going to compile and run, so it will look, this cube will appear. If you press the keys small x or capital X, small y, capital Y, or small z or capital Z from the keyboard, it will move according towards the negative x-axis, positive x-axis, negative y-axis, positive y-axis, or negative z or positive z-axis. So this is your output.